To play the game of Towers of Hanoi, we need three rods, namely source rod, intermediate rod, and destination rod. And we also need rings. Now let us explore the game. Initially, we have three rings arranged in the order of the diameter of rings in the source rod, with the smallest ring at the top of the rod and the largest ring at the bottom of the rod. Intermediate and destination rods will be empty. Our task is to bring the same arrangement of rings in the destination rod. The number of rods is fixed, that is, we have three rods, but the number of rings increases with every level. Say, for instance, you play with one ring in the first level, then two rings in the second level, and so on. We have certain rules to play the game. We can move only one ring at a time. To be more specific, you can move only a ring that is at the top of a rod. You cannot bypass and move the rings. And at any point of time, you cannot place a large ring above a smaller ring. The number of moves we make to complete the task is also an important factor. We are going to look into an optimal approach using recursion that requires 2 power n minus 1 moves for n rings. Let us explore our strategy. First, we shall focus to move the biggest ring to the destination rod. Then let us focus to move the second biggest ring to the destination rod. And if we proceed this way, we shall reach our target. When we move rings from one rod to another, if we just have one ring, we can move it directly. Else, we shall divide the problem into smaller sub-problems and solve them. If we have n rings to move from one rod, say source rod, to another rod, say destination rod, we shall initially move n minus 1 rings from source rod to an intermediate rod. Let us call it as the first sub-problem. The second sub-problem is moving nth ring from source to destination directly. Now we have those n minus 1 rings in the intermediate rod which are to be moved to the destination rod. That is considered as a third sub-problem. When we say we need to move n minus 1 rings, it in turn can have a requirement of repeating the 3 steps again if we have more than one ring. We arrive at the solution using recursion in this fashion. In pseudocode, there are 4 values mentioned inside the bracket that is passed as arguments to the function. The first value refers to the ring number. The second value is the rod from which we are moving the ring. The third value is the rod to which we are moving the ring. And the fourth value is the other unused rod. Let us dive deep into the logic with an example of 3 rings. Our task is to move 3 rings. Here n is greater than 1. So in order to move 3 rings from source to destination, we need to first move n minus 1 rings, that is 2 rings from source to intermediate, as the first subproblem. This task in turn can be divided into 3 subproblems. Move n minus 1 ring, the red ring, from source to destination. Then move nth ring, yellow ring, from source to intermediate. Then move n minus 1 ring, that is 1 ring from destination to intermediate. So we have moved 2 rings from source to intermediate. The first subproblem is completed. Now moving to the second subproblem, move nth ring, that is the blue ring, from source to destination directly. And finally the third subproblem, move those 2 rings in the intermediate rod to the destination rod. This task in turn can be subdivided into 3 subproblems. Move n minus 1 rings, that is 1 ring, the red ring, from intermediate to the source rod. Then move nth ring, the yellow ring, from intermediate to destination. Then move n minus 1 ring, that is 1 ring, the red ring, from source to destination. That's it, we are done. The Python code of this pseudocode is available at the link in the description. To support and encourage this work, do like and subscribe. Thank you for watching.